Hello everyone, I am Mithuna Shreyas from Sri Venkateshwara College of Engineering from the Department of Computer Science and Engineering, studying in 4th SEM Bhaskara. So today we are going to study about analysis and design of algorithms, and the topic we are going to study is insertion sort and topological sort. So the first is insertion sort. So let's know about introduction to the insertion sort. Insertion sort is a simple and intuitive sorting algorithm. It builds a sorted array one element at a time by comparing and inserting. This method is efficient for small datasets and partially sorted arrays. How insertion sort works. The algorithm divides the array into a sorted and unsorted part. Elements from the unsorted part are picked and inserted into the correct position in the sorted part. This process continues until all the elements are sorted. Step by step algorithm. Start with the second element and compare it to the first element. If it's smaller, then shift the first element to the right and insert the second element in its place. Repeat this process until subsequent element. Repeat this process for each subsequent element until the array is fully sorted. Efficiency of insertion sort. The best time complexity is O of when the array is already sorted. Average and worst case time complexity is O of 2 power n due to nested loops. Complexity is O of 1 as it does not require any additional space. So we can see the algorithm of the insertion sort on our right side. Advantages of insertion sort. It is easy to implement and understand, making it a good choice for beginners. The algorithm performs well with small datasets and nearly sorted arrays. Insertion sort is stable, making it maintain the relative order of equal element. For example of insertion sort, for array 5 2 9 1 5, the sorting starts with 2. The sorted part grows with each iteration, resulting in 1 2 5 5 9. Each element is placed in its appropriate position relative to the sorted section. Conclusion. Insertion sort is fundamental algorithm with practical application for small or almost sorted data. Understanding its mechanics helps in grasping more complex sorting algorithms. While it may not be the best choice for large datasets, its simplicity is its strength in certain scenarios. So next, let's go to another topic, that is topological sort. So, introduction to topological sort. Topological sort is an algorithm for ordering the vertices of directed acyclic graph, that is called DAG. The goal is to arrange the vertices linearly such that for every directed edge from vertex A to B, A appears before B. This ordering is crucial in various applications, including scheduling tasks and resolving dependencies. Characteristics of directed acyclic graphs. A directed acyclic graph is a finite graph with directed edges and no cycles. The absence of cycles ensures that a topological ordering is possible. Many real world problems can be modeled as DAGs, such as project scheduling and course prerequisites. So the next is types of topological sort. There are two primary types of topological sort, that is Kahn's algorithm and depth first search based method. Both methods procedure a linear ordering of vertices but different in implementation and approach. Understanding this method is essential for effectively applying topological sort in various contexts. The first one is Kahn's algorithm. Kahn's algorithm uses a queue to maintain vertices with no incoming edges. It repeatedly removes these vertices from the graph and add them to the topological order. The process continues until all vertices are removed or a cycle is detected which indicates failure. The Kahn's algorithm steps are as follows. Initialize a list of topological order and a queue for vertices with no incoming edges. While the queue is not empty, remove a vertex and add it to the order and decrease the incoming edge count of its neighbor. If any neighbor's incoming edge count drops to 0 and it to be queue for the processing. The next is DFS based topological sort, that is depth first based topological sort. The DFS based method relies on exploring the graph deeply before backtracking. It involves marking nodes as visited and adding them to a stack upon completion of exploration. The final topological order is obtained by reversing the stack after all the vertices are processed. As we see in the image, the elements are re- removed and then the array is formed by arranging the elements. DFS based topological sort steps starts with an unvisited vertex, mark it as visited, and recursively visit all its adjacent vertices. Once all the adjacent vertices are processed, push the current vertex onto a stack. After processing all vertices, pop the elements from the stack to retrieve the topological order. Comparing the two methods. Kahn's algorithm often provides a more intuitive understanding of dependencies through its queue based approach. DFS method can be more efficient in terms of space as it primarily relies on recursion and a stack. Both methods ensure that the resulting order compiles with the constraints imposed by the graph edges. Conclusion. The topological sort is a fundamental concept in graph theory with practical applications. Understanding both Kahn's algorithm and DFS based method allows for flexibility in solving problems involving dependencies. Mastery of these techniques is vital for computer scientists and engineers working with directed acyclic graphs. Thank you.